Now, how do we factor sum of two squares and difference of two squares? Now, first we have to review our perfect squares. So here's our list of a few perfect squares. So we should be able to recognize perfect squares. So if we look at this, 4x squared minus 25y squared, we notice that both of these are perfect squares. And since this is minus, then we call this a difference of two squares. Now, can we factor this? We can think of this as the area of a rectangle. And we want to find the length and the width of the rectangle that gives us this area. So 4x squared goes here, and 25y squared goes here. Now we want to find the factors of 4x squared, so that it's going to give us 2x times 2x right here. And then for 25, it's going to be 5y times 5y. Now we want these two empty spaces here to cancel each other because we only have two terms in the product. So if we multiply 2x by 5y, we know we're going to get 10y. If we make this positive, 10xy. So if we make 5y positive, then we get positive 10xy. And if we want the other empty space here to be opposite of this one, so we want this to be negative 10xy, so we can cancel. Therefore, this 5y over here should be negative. So the factor should be one sum and one difference. And let's double check. 2x times 2x is 4x squared. 2x times 5y is 10xy. Negative 5y times 2x is negative 10xy. And negative 5y times positive 5y is negative. I forgot to put the negative earlier. So it should be negative 25y squared. So therefore, if we get the area, it's going to be equal to this polynomial that we have here. So now we found the factors. The factors are 2x plus 5y times 2x minus 5y. All right. Now, we notice that 16x is second is also a perfect square, and this is a perfect square too. 9 is a perfect square. However, this is not a difference of two squares. If we have a sum of two squares like this, we cannot factor it like we did the difference of two squares. So we'll just say this is not factorable under real numbers. Okay, for now we just want to find factors that are real numbers. Okay, now 9x minus 16. Is this a difference of two squares? Now, because 9 and 16 are perfect squares, but this x is not a perfect square. So therefore, we don't have a difference of two squares in here, so this cannot be factored. Okay. 81m to the fourth minus 16p to the 8 is a difference of two squares because this is minus and these two terms here are both perfect squares. So we can factor this. We know we'll have two binomial factors. First factor should be 9m squared minus 4p to the fourth, and 9m squared for the second one plus 4p to the fourth. Now, notice that 9m squared minus 4p to the fourth is another difference of two squares, so we can still break that down. So we'll have here 3m minus 4p squared times 3m plus 4p squared. These are the factors of this. So now we just need to bring down this other factor, which is a sum of two squares, and we can't factor it anymore, so we just bring it down. 9m squared plus 4p to the fourth. Now we're done factoring this polynomial.